The standard picture of the universe treats matter as a fixed legacy of the Big Bang. A finite supply of hydrogen and other light elements was produced in the first few minutes, and everything that has happened since is a rearrangement of that original inventory. Stars fuse hydrogen into heavier elements. Those elements are scattered by stellar death, and the cycle continues. The total amount of matter is conserved. But what if the amount of matter in the universe is actually increasing? What we see of other galaxies is what they looked like hundreds of millions of years ago. We don't actually know what they look like today. What we do know is that hydrogen is far more abundant than every other element. What if the reason for that is that hydrogen is continually being created? In wave physics, a knot forms when enough energy concentrates in a small enough region to push the membrane past its yield threshold. Below that threshold, any disturbance is temporary. The membrane restores itself and the energy disperses as radiation. Above it, the membrane undergoes a permanent topological change. In a subset of such instances, the same trefoil knot we met in Video 6 locks into place. New matter exists where none did before. This is not spontaneous creation from nothing. The energy comes from the surrounding membrane. The knot formation releases some of that tension as heat and locks the rest into the permanent topology of the new knot. Matter is not created from nothing, it is minted from the membrane's own tension, the way a coin is minted from metal that was already there. The question is whether this happens in nature, and if so, where? Stars are the most natural candidate. The Sun fuses roughly 9 × 10⁻37 protons into helium every second. Standard models assume a closed reservoir. What is fused is gone, and the Sun has about 5 billion years of fuel remaining. But the solar wind, the continuous outflow of plasma from the Sun's corona, carries an enormous flux of protons outward, and its composition has shown no strong sign of hydrogen depletion over the time we've been able to observe it. Wave physics proposes that the extreme energy densities in stellar interiors may produce occasional collisions sufficient to exceed the yield threshold, minting new hydrogen knots at a low but steady rate. The energy required is drawn from the membrane tension already present in the stellar environment. If this occurs at even a fraction of a percent of the fusion rate, it would affect standard lifetime estimates significantly, since those estimates assume no replenishment at all. This is a hypothesis consistent with the data. It is not yet uniquely required by the data. The absence of observed hydrogen depletion is also consistent with standard models, since the Sun's total hydrogen reservoir is enormous relative to what fusion consumes over observable timescales. Distinguishing between the two would require long-term monitoring of the solar wind's isotopic composition for deviations that replenishment alone could explain. The gas giants offer a second line of suggestive evidence. Jupiter radiates about 1.67 times the solar energy it receives. Saturn radiates about 1.78 times. Neptune radiates about 2.61 times. Uranus shows little to no measurable excess. Wave physics proposes that wherever a planetary interior exceeds the membrane's yield threshold, knots are minted and heat is released as a byproduct. The factors that determine how frequently the threshold is exceeded are not yet fully understood, but interior pressure, core density, and tidal stress from satellite systems all appear to play a role. Jupiter's extraordinary tidal interactions with its moons may explain why its measured excess is lower than its mass alone would suggest. Much of the energy appears as volcanic activity on its moons rather than as radiation from the planet itself. Uranus, with a less dynamically active moon system and a larger but less dense interior than Neptune, shows essentially no excess. Why these four apparently similar planets differ so dramatically remains an open question, and any complete account will need to explain all of them. There is a broader implication to the minting of new matter. If the membrane can create new hydrogen atoms wherever local conditions exceed the yield threshold, the universe is not a closed, depleting system slowly running down toward heat death. It is a dynamic substrate whose material content can be renewed wherever sufficient energy concentrates. The universe may be, in a very literal sense, still making itself. In the next video, we will discuss the cosmic microwave background and the assumption that it represents leftover heat from the Big Bang.